So if you could open up your 7-1 homework and look at the last section, problem number 47, we're going to do that together just to kind of make sure we understand how a right triangle works. So then we can move on to section 10.1, how what's called an oblique triangle works. Okay, so for this section and the next section, you're going to see where it says solve each triangle. To solve a triangle, you have to know the value of every side length, customarily to the nearest tenth, every angle measure, usually to the nearest degree. Okay, so let's analyze what we know in problem 47. So we know little a is 6. That's the only side that we know. Now, it's customary also for our angle measures to be capital letters, many times A, B, C. If they didn't use a Greek letter inside the angle, they'll use a vertex of A, B, and C. The one across from the angle A will be small a. All of our sides, customarily, please make them lowercase letters. So big A goes across from little a, big B goes across from little b, big C goes across from little c. So then we can definitely identify them as a, what pair goes with what, okay? Now for a right triangle, we have 3 things that we know about a right triangle. The angles always add up to 180. That's one thing we know. We know we can use the Pythagorean theorem. We know we can use any of our trig functions. So we have 3 tools that we can use for a right triangle. So for this, one of the easiest things, since we know that angle A is 20 degrees and angle C is 90 degrees, we know that angle B is 180. Take away those things. Now, one thing we also know is for a right triangle that the 2 acute angles will always be complementary. They're always going to add up to 90 so that the other 90 total will total 180. So we know this is 70. So now we have all of the angle measures. Let's talk about the side lengths. Now, if we know 2 side lengths, we can always use the Pythagorean theorem right off the bat. If we don't have 2 side lengths, we are forced in a right triangle to use SOHCAHTOA. So the original angle we were given was A. We know side A would be opposite if we use this angle here. And then, I don't know, we can find either one. Let's do the adjacent. Another fact you should know, the smallest angle should be across from the smallest side. The medium angle would be across from the medium side. If 2 angle measures are the same, they've created an isosceles triangle, so those 2 sides across from them would be equal. You learned that hopefully in geometry class. And for a right triangle, our hypotenuse is across from the largest angle, so it's going to be the largest side. Okay, that being said, let's find side B. So side B, since we know A is 20 and little a is 6, the tangent of A is going to be opposite over adjacent. Okay, so now we have a tool for us to solve for B, little b. Now it's customary algebraically, whatever's in our denominator, cross that over. So this would be the tangent of 20 times b would equal 6. So now we need to get that b by itself, so just divide through by the tangent of 20. So b would be 6 divided by the tangent of 20. Now, we know that b should be bigger because it's across from a 70-degree angle. And so if we do that calculation and we round to the nearest tenth like they wanted, 6 divided by the tangent of 20 is 16.5. So just do angle measures to the nearest degree and side lengths to the nearest tenth, unless the instructions say something different. Okay? Now, what's nice about as soon as we know 2 sides in a right triangle, we now get to use Pythagorean. Now, we could have also used sine or cosine at this point to find that hypotenuse, because each of those contain an h, a hypotenuse. But I like using Pythagorean because I know that a squared plus b squared has to equal c squared. Now, a and b are always the legs. the smallest sides, so that would expect us to get that largest side for our hypotenuse. So we know that a squared is 6, b squared is 16.5 squared, will give you c squared. 6 squared plus 16.5 squared is 308.25 is c squared. So c is the square root of that. And we should expect a number larger than 6 and the number larger than 16.5, since our hypotenuse should always be the longest side. So c, when rounded to the nearest tenth, is 17.6. Okay, and then just kind of glance through when they say to solve the triangle like they have here. Do I know all 3 angles? Yes. Do I know all 3 sides? Yes. Okay, then you know you're done. And there are lots of ways to do it. You might have decided to use another trig function like tangent or sine or cosine. Sine or cosine would also find you the hypotenuse. You might have started out, found the hypotenuse, and then then did Pythagorean theorem. There's so many ways to do this, but that is the answer to 47 from the 7-1 homework. Do we have any questions there? Have any questions about 47? Okay, so I wanted to kind of revisit that before we moved on. So now at this time, if you can find the 10-1, 10-2 note sheet that is in Google Classroom under the 10-1 homework post. Find it, open it, but we're going to talk about the law of sines. Now in 10-1, we are going to talk about the law of sines, and then we'll talk about the law of cosines. An oblique triangle is a triangle that is not necessarily a right triangle, where all 3 angles could be different, or it's just not a right triangle. Up to this point, we have done right triangle trigs, so we could only solve if we knew it was a right triangle. In real life, most things are not a perfect right triangle. Every day when you use your cell phone is pinging off of 3 nearest cell towers. Most of those things, when it says you're triangulating your signal, most of those triangles are not right triangles. Most of them are oblique. Most real world situations use triangles that are not quite perfectly a nice right triangle. So we need other tactics that we can use. And so the law of sines and the law of cosines are going to help us. And the first one I want to talk about is the law of sines. For any triangle, you can even use this for the law, or for a right triangle, it will work. But for any triangle, if we know that side A, little a is across from capital A, little b is across from capital B, little c is across from capital C, if they're across from each other, this particular, I've written it a little bigger, this formula holds that the sine of A over A is equal to the sine of B over B. So you could use those two. You could use these two. You could use these two. You can use any combination of the two to find a piece of information that you're missing from your triangle. As long as you have one pair that is a full fraction. So you have to have 3 things to use the law of sines, and one of them must be a completed side angle pair. So you have to know either both A's, both B's, or both C's to use the formula. So the only way we can use the law of sines is if we have a finished cross pair. So side A and angle A, side B and angle B, side C and angle C. That's the only way to use this. So there are some limitations. There's also what's called an ambiguous case. Sometimes it's referred to as the hinge problem. If you know, just kind of remember in back for congruency, side angle side worked, angle side angle worked, but there was that one that didn't, that side angle didn't work. It can cause some issues. We're going to mostly work on ones that actually do work, okay? Okay. So now that we know a formula, let's solve a non-right triangle. So let's look at example 1. It says to solve triangle LMN, So we want all angles and all sides, and we're going to round sides to the nearest tenth and angles to the nearest degree. Okay, so first I kind of look at, do I have a side angle pair? Well, you'll notice I have L and I have little l. So let's put a little l here. I make a little l kind of in a cursive L fashion because my other L's don't look like little l, so that's the L you get from me, okay? So we have a finished pair. That tells me I'm allowed to use the law of sines on this problem. Otherwise, can't use it, okay? One thing I do notice is we have two angle measures. To find a third, we could always use the 180 rule. So angle N is going to be 180, take off 112, and take off 29. So if you have two angles, very easy to find the third. Just do 180 minus 112 minus 29. And that's going to keep it rounded to the nearest whole like they want it anyway. So this is 39 degrees. Let's put it there. Okay. So let's think about what we know. We know that L is the smallest angle, so will be the smallest side. N is the next biggest side, and M will be the largest angle pair side because it is the largest angle. Okay, so keep that in mind. That's a good way to check that you're doing it right. So let's write down the pair that we know. The pair that we know is L. So the sine of angle L over little l. And then let's use this formula to find either M or N. It doesn't really matter which. Pick what you want. Let's just start with M because that's what we started with initially. They gave that to us. So I know the sine of angle M over little m. So let's check. This is L. They're across from each other. This is M. They're across from each other. So that's the way to tell that you've set the law of sines up correctly. Now what you're going to do is you're going to cross multiply to solve for your missing variable, wherever it's at. This is a proportion, so you can't just cross multiply a proportion to solve it. So I know that the sine of 29 times M is going to be the sine of 112 times 22. Now keep in mind, M should be our largest side when we're all done, because it's across from our largest angle. So think about the fact, to solve for M, I need to divide. So it would be the sine of 112 times 22 over the sine of 29. Okay, so let's put that into our calculator. The sine of 112, make sure your calculator is in degree mode, times 22 divided by the sine of 29. We should get a number bigger than 22 because it is our hypotenuse. They said to round side lengths to the nearest tenth. That is 42.1. They did not give us that it was feet or inches or whatever. If they do give you the units, please write them. If they don't worry about it. Okay. So now we are done with M. We now know that this is 42.1. Okay. So now let's set it up again. You can use the M pair if you want now because it's a finished pair, but I like to use the one that they gave me initially. So the sine of 29 over 22 is my go-to because they gave that to me. And now the last thing we need to find is little n, the side length n. So I know that that's across from 39 degrees we found earlier over little n. So now that's just a proportion. Solving proportions easy, just cross multiply and then divide. So we get the sine of 29 times n will be the sine of 39 times 22. So n is just the sine of 39 times 22 divided by the sine of 29. So we're just going to put that into our calculator. So the sine of 39 times 22 divided by the sine of 29. So that is going to be 28.6. Okay, so this is how I check my work. So let's put that back on our triangle. Okay, the way that I check my work is this. Is the smallest side across from the smallest angle? Yes. Is the medium side across from our medium angle? Yes. Is our largest side across from our largest angle? Yes. So just taking 2 seconds of your time to check that that relationship holds means you probably did what we should have done correctly. If that relationship doesn't hold, because it always has to hold, then go back and check your work. You did something funky. Okay? Do we have any questions about example 1? So we know all sides, know all angles. Now you know you're done with the problem. Okay? Okay. Now I would like to do an application problem, and then you'll have the rest of class to work on this homework. Okay, so let's take a look at example 2. We have this balloon that's floating between 2 buildings. The buildings are 650 feet apart. The angle of elevation to the top of our, from the top of our left building to the balloon is 62 degrees. And I'm going to make that a little bigger for you so you can see it from that. The angle of elevation from our rightmost building is 49 degrees. They say, find the distance from the hot air balloon to each building. So they've called these vertices X, Y, and Z for reference. So this is going to be little x, this is going to be little y, and this is going to be little z. Okay? So they have used that same notation where the vertices are uppercase letters, the sides are lowercase letters, and the letters should match up if you check across from each other. Okay? So we need to find x and y. So the first thing I always think to myself is, do I have a finished pair? Well, this is missing something, that pair. Y is missing a side. X is missing a side. And Z is missing something. So there's got to be a way for me to have a finished pair. Can anybody tell me a quick way to find one more piece that we're missing? Yes. Exactly. Find that angle that you're missing, because that's a really quick fix. So angle Z is going to be 180 minus 62 minus 49. We'll have now a pair. Okay, so 180 minus 62 and minus 49 is 69 degrees. Let's put that in there. Now, 69 degrees is our middle angle. Oh, no, I'm sorry. It's our largest angle. So that means 650 feet is the largest side length. So both side lengths should be less than 650 as we go through this process. Now this one's across from 62. So Y is probably going to be pretty close to 650. Our smallest side would be side X. So keep that in mind as you go through the calculations. So think about the pair we know. For the law of sines, it's sine of Z over Z. So the one we know is that 69 degree and 650 feet pair. So that's one we're going to use 2 times to find X and Y. Let's start with X. I know that the sine of angle X, which is 49 degrees over X, is going to equal that Z over Z is X over X. Okay. So now it's just a matter of solving. X times the sine of 69 degrees is the sine of 49 degrees times 650. So just cross multiply. And then you have to divide off that sine of 69 to find it. So X is going to be the sine of 49 times 650 divided by the sine of 69. Okay, so let's do it. And remember, X should be our smallest side of all. So the sine of 49 times 650 divided by the sine of 69 is, we'll go to the nearest tenth because that they didn't tell us otherwise, and that's a common 4 lengths, is 525.5 feet. Okay, so that's X. That is the distance from the left building up to the balloon, 525.5 feet. Now, 62 degrees is between the 2 angles that we already had. So its measure should be something between 650 and 525. So that's a way to kind of check our work. Let's set it up one more time. So I'm going to use this again, that original information we knew about z. So the sine of 69 over 650 is my z pair. Now let's set up my y pair, okay? So that's going to be the sine of 62 over y. So that's my y pair, and that's going to help me solve for y. Cross multiply, then divide, same thing every time. And so to solve that, I know that the sine of 69 times y should be the sine of 62 times 650. So y is the sine of 62 times 650 over the sine of 69. Okay, so let's put that into our calculator. So the sine of 62 times 650 divided by the sine of 69. Remember, we should get something between 525 and 650 since our angle is between 69 and 49. If you throw that into a calculator, we do indeed get something between 650 and 525. We get 614.7 feet. So then just do a quick little check. Is our smallest side across from our smallest angle? Yes. Is our medium side across from our medium angle? Yes. Is our largest side across from our largest angle? Yes. So that is a super quick check. You don't even have to put anything into a calculator to check your work. Is the smallest across from the smallest? Is the medium across from the medium? Is the largest across from the largest? So it's a very quick little check you can do. Okay. Do we have any questions about our application problem? Okay. So problems 1, 2, 3, and 4, you're going to do like the first example we did. Problem 7, I need to draw that picture for you. So let me read the problem, and I've drawn the picture for you so you have it. It says a golfer misses a 12-foot putt. So here's where the ball was to start. It is 12 feet away. Now this is not to scale. This is just a placeholder for my information, just so you know. It is not to scale. The X value you're going to get is very small, so you know, okay? He was off by 3 degrees. So it's very hard to make it the correct 3 degrees. It's very tiny, but he's off by 3 degrees. And now he is an X distance from the putt. That's what we're trying to find. How far away is he now from the putt? If the angle he created is 129 degrees between the ball and its spot before the putt. So here, okay? So that is the picture for number 7. You are trying to solve for X. You should be able to use the law of sines. Okay, so you have the rest of the period to do this. Please make sure you turn this in by the time I see you tomorrow at the beginning of class. So if you have any questions, you can ask those questions. Okay, so work on those now.